Okay, here's some more of homework 4.2, and this is number 23, and this is f of x equals x times the square root of 4 minus x. And again, let's check our domain. We know that 4 minus x must be greater than or equal to 0, so 4 must be greater than x. If I add x to both sides, or x is less than or equal to 4. So my domain is negative infinity to 4. Can be equal to 4, so I can go right up there. And we want to find the same as the previous problems. We want to find the relative extrema. Okay, we want to find the relative extrema, and then we also want to find where it's increasing and decreasing. So we take a look at the intervals here, or we take a look at the derivative. We take the derivative. We're going to use the product rule, first times the derivative of the second, which is just going to be, use our square root, 1 over 2 times the square root of 4 minus x times the derivative of negative x, which is negative 1, plus the second times the derivative of the first. The derivative of x is just 1. And then we'll try to make it one fraction. So it looks like this will be my LCD. So first of all, I'll make this negative x all over 2 times 4 minus x. And then I'll take this square root of 4 minus x. And then I'll multiply the top and the bottom by 2. And square root of 4 minus x to get a common denominator here of 2 times the square root of 4 minus x. So this just becomes my negative x. This is all over my LCD now, 2 times the square root of 4 minus x, and then I've got 2, and then 4 minus the square root of 4 minus x times the square root of 4 minus x is just 4 minus x. Then if I multiply that by 2, there's my negative x, and then 2 times 4 is 8. 2 times negative x is negative 2x, and I can say 8 negative 3x on the top simplifies. Okay, so there's our derivative. We did some algebra to simplify. Now, where is that equal to 0? Well, it's equal to 0, and the numerator is equal to 0. So that's just x minus 3x equals 0. So, I'm sorry, 8 minus 3x equals 0. So add 3x to both sides, and then divide by 3, so x equals 8/3. Where is it undefined? When the denominator is equal to 0, so that's when x equals 4. Now, that is the endpoint. If we remember our domain from up here, that's our right endpoint. So keep that in mind. So we can put our 8/3 and our 4, but then it's undefined to the right, so that's our right endpoint of our function. And we can put some values into the derivative. If I put 0 in here, well, this bottom's always got to be positive, so I don't have to worry about that. So if I put 0 in the top is positive. If I put 3 in the top, that's this 8/3 is 2 and 2/3, so this is just to the right of 8/3 at one critical number. These are my two critical numbers again. One being an endpoint. All right, one of the critical numbers. All right, then if I put 3 in here, 8 negative 9 is negative 1, so that's the negative. So this is what's happening with my derivative. It's positive, so my function is increasing, and the derivative is negative, so my function is decreasing. All right. And then we want to find the point that goes with 8/3, so we can just put f of 8/3, and that's going to be 8/3 the square root of 4 minus x, or 4 minus 8/3, if we look at our original function up here. Sorry, this one here. So that would be 8/3 minus the square root of 4 minus 8/3. Well, 4/3 is 12/3. 12/3 minus 8/3 is 4/3. The square root of 4 is 2, so I can take that out of the radical. So I've got 8 times 2 is 16 over 3 square roots of 3. So take a look at that arithmetic. Hopefully that makes sense to you all. So that's the y-coordinate of my relative maximum. This is a relative maximum because you can see how it's going positive to negative. So there's a relative maximum at 8/3, 16 over 3 square roots of 3, because f prime changes from positive to negative there. Okay. Now, this is a right endpoint, but if you can look, you can see that the function is decreasing up to that point. So since it's decreasing up to that point, it looks like the right endpoint will be a relative maximum because it's coming down to it. So relative minimum. The right endpoint will be a relative minimum because the numbers to its left are greater than it because it's descending to that point. It's coming down to wherever that is. All right, so it's a relative minimum at 4, 0, and endpoint because f prime is negative to the left of 4, 0. Now, I got the y-coordinate because I just put 4 back into the original function. If I put 4 back into the original function, that's easy. 4 times the square root of 4 minus 4 is 0, so 4 times 0 is 0. So that's how I got those coordinates, all right? So I hope that makes sense. All right. It's a relative minimum and endpoint because f prime is negative to the left of the right endpoint. Okay. We maybe should have said it's a right endpoint or a right endpoint. And if f prime is negative to the left of a right endpoint, then that right endpoint must be a relative minimum. Okay? Now, since f prime is greater than 0, f prime is greater than 0 from negative infinity to 8/3, then we could say that f is increasing. Okay, f of x, and they were just asking the intervals, but we could say f of x is increasing on the interval negative infinity to 8/3 inclusive. And since f prime is less than 0 on 8/3 to 4, you can see it's negative, it's less than 0, then the function is decreasing, so we could say f of x is, the function f of x is decreasing. Okay? On 8/3 to 4 inclusive. The only time when we're talking about these decreasing and increasing intervals, the only time we have a parentheses rather than a bracket or open is when we have infinity or negative infinity. Okay, hope that helps.